Welcome to the week 7 of the course Computer Aided Decision Support Systems, Big Data Analytics in Practice, where we are trying to learn how do we implement the big data or how do we handle the big data. Various query languages are discussed in the first few weeks, and you also had a brief introduction on the markup language HTML. PHP would be discussed by Professor Deepu Philip in the coming weeks. I have discussed an introduction to the life cycle of the big data analytics. What are the various steps, what are the various stages, what decisions could be taken, what kinds of data could be put in. An important discussion to be taken in this week is big data analytics and IIoT. IIoT is Industrial Internet of Things. This week would flow through the Internet of Things. Then what is Industrial Internet of Things specifically, the structure of an IIoT system and its elements, the big data analytics in IIoT in general, and a case study on Rolls-Royce engine where the service or the product is taken as a service. So, performance per hour model or PBP model, pay by performance model. So, how is that possible while using the Internet of Things? That we will see, and how is big data analytics helpful in creating this kind of the service that Rolls-Royce is now acing in. Let us have a brief introduction of what is Internet of Things. Internet of Things, as the name describes, it is connection of the various objects or groups. If you take the example of Alexa, a home managing system, it supports Google, which supports Apple, Siri, where we try to switch off the lights, where you try to have the weather information, where you try to have anything that you like to access in the Google itself, your computers can switch on by itself. How is this connected? The idea of Internet of Things was provided way back in late 90s, maybe in 1987, when Dr. Hong Thon created a pipeline system in which he wanted to control or have the information from the different control points in a pipeline system. However, this case was published in late 90s, maybe in 1999. But Internet of Things took its trajectory only when the RFID came into existence, that is radio frequency identification, which in 2005, from there it has reached to what we are now in Industry 4.0. So, what is Internet of Things? If I need to put a definition of it, Internet of Things is physical objects or group of physical objects these are equipped or connected with sensors, processing power, softwares and other technologies, so that they communicate or connect with each other and exchange data over the internet or other communication networks. So, these objects try to have a periphery of sensors, then processors or power systems, a software and so on. They try to, number one, connect or to communicate. When I say connect, they are trying to having links between them. When I say communicate, they try to exchange data and information. The time Internet of Things has been used now when we try to connect most of the sophisticated objects, such as we might have machine learning algorithms connected with them, between some expensive sensors even, but inexpensive sensors, the potent embedded systems are also part of it. So, IoT is enabled by the traditional fields of embedded systems, wire sensor networks, control systems, I will put it here, control systems as well, and maybe automation of all these systems. The IoT products are often more associated with for us as a normal consumer, it is a smart home, the Alexa data example I gave it to you. So it can be, when we say for a consumer, it could be a smart home system. For a general consumer, for the people who are into industry or maybe in manufacturing, Internet of Things means something else to them. It means better products or system automation. For a big enterprise in manufacturing, it is fine. We need to produce better products, we need to produce the products with a better quality, and automation of the system, material handling, what are the number of materials or number of the units those are there at from one point to another, maybe from machining center to the finishing center, what are the number of units those are there. This all could be there in a manufacturing concern. At an enterprise level, Internet of Things means they need to have better resources in a way. Here, what are the connections or what are the elements we need to work upon? Time, energy. Time could be, say, when we try to have a minimum latency between the transfer of the materials, the minimum latency between the storage on where what to storage, like cross-docking in the Walmart case study that will be discussed by Professor Philip, how the cross-docking of the trucks help to have less number of trucks even. So time between the delivery or for the delivery was also reduced. So time, energy means it could be energy that it is embodied if it is cross-docking, the fuel that is saved, that is also energy saving, and energy saving in bringing or purchasing less number of trucks or so, that was also a cost saving or so. Or cost saving here means it is energy saving as well. So it is also for an enterprise level, if they wanted to have a paperless workflow. In the corona era, we had digital signatures, maybe very streamlined by many of the applications. The documents which were processed by a few professors, maybe at IIT Kanpur, the PhD Viva was, or the defense of the people who were conducting their MTech or PG thesis at IIT Kanpur, their assessment happened at Zoom or some other platforms like those. Then signatures happened through digital way. And at enterprise level, this is always targeted because this also reduces your work or reduce your time to access everything. Then at enterprise level, one of the important factor Internet of Things helps us to do is risk assessment and so on. Government bodies also like to have Internet of Things, where it provides them an ability to track different kind of resources and an improved way to connect to their citizens. Better way to connect to their citizens. For example, for the MSMEs companies, there is an app or there is a portal known as Udyami Mitra, where the people would like to log on their problem they have in applying for loan, or maybe the kind of technical queries that they have, that could be addressed by the people who have expertise in the SIDBI Bank itself. SIDBI Bank provides loan to MSMEs companies who also apply through Udyami Mitra. This is a connects to the people. Then people have different mobile phones, they have Android applications which farmers also use to update the status or the health of their crops or so. So those things also help the people to connect between themselves. So this is a general introduction of what is Internet of Things. So there are certain challenges that Internet of Things is still facing, because still there is skill shortage, there is a major skill gap that needs to be eliminated, and only a limited number of professionals have expertise or skills in the field, and it is expected to grow. That is why these courses are being introduced, so that you have a basic introduction of how do we connect from starting very ingesting of the data to developing the finally web based using a markup language, so that we can develop the applications, even the applications which are existing in the market, one should be able to understand what is the GUI of them and try to work upon them, try to improve them, try to give the feedback on them. So, the Internet of Things helps in all these sectors. Next comes industrial Internet of Things. When I say Internet of Things, it is just connection that happens in a computer integrated manufacturing. It was a very basic term which has now become a very generic term which we are trying to work upon for the last 30 years or so. So, when we say CIM, computer integrated manufacturing, it includes computer aided design, it includes computer aided engineering, then computer aided manufacturing, flexible manufacturing systems, process planning, and so on. Multiple things are there. Now, with the induction of the RFID, QR codes or small systems that can connect small sensors with each other, this has also taken a big pace. So, this was basically a small Internet of Things only that can happen at the house level only or at a government bodies that would like to connect to them. When I say industrial Internet of Things, here the word industry comes into play. In IIoT, it is not only Internet of Things, but we also have the cloud computing. Cloud computing, that is the computing happens at cloud. There is no requirement of much storage at the computer or the physical system itself. Then we have automation. Automation such as we have intelligent robots. In product assembly line itself, the robots are intelligent enough to identify in the maybe food industry itself. So, what is the kind of the guava that is coming? What is the color of the guava? Whether it is acceptable or not? Then there is a penetration test. The robot would like to have a penetration test where the sensor is there, piezoelectric sensors kinds of the things are there, where they try to sense whether the pressure that is being made on that fruit that is being acceptable or not. So, is the pulp, what is the pulp or what is the weight of the fruit per volume? All these things could be identified by the robots itself. So, the robots are intelligent enough. I am talking about the food industry because it is very tough to really replicate or try to imitate what humans could do in artificial intelligence. Otherwise, in manufacturing concern, trying to see size of a box or so, for example, this size, what is the radius is correct or not, height is correct or not, this is okay. This is why one caliper, why a robot inducted with a one caliper kind of a system could measure it. But in food industry itself, there is an automation, the robots are intelligent enough like humans, and this could be reprogrammed and try to, we can also have different kinds of setups, advanced control algorithms set in them. Then along with intelligent robots, we have Internet of Services. Internet of Services mean anything that is required to use a technology or a soft application and that is available as a service on the internet. For example, the Windows itself is Internet of Services now. For example, any drive program that you try to run to scan a sheet on of your notes or so, that use Internet of Services as well. How do you connect that? Where do you connect that? So, that is Internet of Services. Along with Internet of Services, we also have wireless technologies. Then AR, that is augmented reality. I can't cover all of them in this one small course, but yes, many of these are connected to the Internet of Things or industrial Internet of Things. That is how we call it as concentric computing. That is at a central level, computing is there, which is connected to different systems, and we have an industrial Internet of Things. So, this helps to a cross platform integration leads to in which IoT systems must ensure three major parts. Number one is security, number two is virtualization, and real time capability. These are the verticals of it. So this happens while we have a good service orientation, or oriented service oriented, I will say oriented service also, and at some points decentralization of this is also required. At times only, and interoperability. So few traits like the system should be self-aware, self-predicting, self-comparing, self-maintaining, self-organizing. So these are sometimes completely not fully available or fully completely imitating the human is not possible, but yes, to whatever extent we can integrate, Internet of Things could help, or industrial Internet of Things could help. So in real time capability, let us consider maybe Rolls-Royce engine that I will take as a case study as well. If suppose the temperature is also to be monitored, or the pressure is also to be monitored, and each second we have to record in the real time sense, and that is to be connected to various other points, whether how the temperature varying, according to that what is the fuel injection that is coming, and according to that how the engine operation should go, what is the maximum speed that the jet could fly or so. Rolls-Royce engines are being used in jet flying or so. For each second, if it is recorded in 60 seconds, 60 data points for only one parameter, and for 1 hour 3600 data points, and if it is to be monitored for 10 hours, consider 36,000 data points only for the temperature at one point, right, at engine, maybe surface of the body or surface of the fins of the propeller that is there, right. So do we really need all these data points, and how could these be connected? So this makes big data as an inevident or irreplaceable element or the part of the industrial Internet of Things, because we have to have big data, we have to have programs which should be able to retrieve the data, though the data is there in the cloud most of the times, but still to run a program to get the data from there, then map reduce them. Sometimes we need to have more complicated testing done on them, so that we have proper regression models run on them, what are the significant temperature points where that we could record or so. So all these things are there in the Internet of Things. So what I can write here is that BDA makes it possible for IIoT systems to provide value for its money. How we create value or knowledge from the data. So this knowledge is created from the data, and the data that is collected through cross platform integration. So it is data available in high volume, maybe coming at high velocity, and variety of the data is also there, veracity could also be there. The big data analytics refers to the process of gathering, managing, processing, or maybe visualizing the data that is continuously evolving. So this creates an unrestricted internal and external activities. So what technology we generally have, we call it as operational technology. Operational technology means it is something that makes certain that a company efficiently turns inputs to the outputs and in an efficient way. So, it is collection of the gadgets that are developed through work together, that how do we operate the system or so. So, operational technology may include the plant operation facility, then maybe sensors or PLC, then edge softwares, then embedded system networks. Here this is all is taken to monitor the shop floor machines. There could also be a human machine interface here as well. So, there could also be a human machine interface, human machine interface. Another thing is that we have been talking since beginning is information technology. Where the information is processed, and then we try to, where the data is processed, actually the data is processed to get something useful out of it that gives us then information. The pieces of information are collected and we try to gather them and collect them, make clusters out of them, so that we try to have a good knowledge developed out of that. That knowledge helps us to develop the small programs for our artificial intelligence, which is taken through the big data analytics only. So, information technology and operation technology together, they mingle to form Internet of Things. We have on this side monitoring. On the operational technology, we have monitoring the shop floor machines with human machine interface as well, which is the plant operation facility, sensors, PLCs, software, embedded system and networks. And in information technology, we have the ERP systems or so, which are enterprise resource planning systems, then asset management, then communication technologies, maybe network and cloud infrastructure or security, then machine learning as well. Here machine learning is something equivalent to what we have edge computing here in the operation technology. So, in information technology we have machine learning. These interact with each other. So, operation technology and information technology interact with each other to develop a system in which sensors are the all operational and systems are there which connect to the information and makes us to have an industrial Internet of Things. So, operation technology and information technology have had relatively separate roles within an enterprise till the point the Internet of Things as a concept came into play. The product and plant managers in reality operated in industrial control systems in a separate network, previously literally set apart from each other and secured from the other areas like their production environment or enterprise system for safety or security reasons sometimes. So, with the introduction of the IIoT, this allowed the integration of the integrate physical machinery with network sensing units. So, this allowed the integration of intricate physical machinery with network sensing units and software. That is, hey, this is OT, this is connected to IT. Now, the connection between the operation technology domain, which entails automation of the shop floor, supply chain monitoring, enterprise asset tracking. So, where information is produced, the information technology domain entails the business process automation, where data are consumed. Now, the conglomeration of the OT and IT is a key factor to achieve a smart manufacturing. Or I would say digital manufacturing. So, emerging technologies like machine learning, artificial intelligence, which are driving the OT-IT integration. If I say OT-IT, it is OT-IT integration. This is equal to IIoT. So, this allows the straight control and complete tracking with an more controlled evaluation of the data of the enterprise manufacturing facility, which is distributed across complete globe in a way. Integrated OT-IT systems result in efficient processes and efficient operations. So, I would like to discuss case studies in the next lecture, where we will see how industrial IoT is being supported by big data analytics to have an output which industry has proven to be very helpful or very profitable to them. Thank you.